Welcome to CGS Tech. Construction 3D printing is a manufacturing method of depositing a material like concrete, layer by layer, via an extrusion machine that can move autonomously according to the preset layout. This can produce concrete structures with a significant degree of design flexibility and build faster with less manual labor involved. Construction 3D printing has the potential to greatly impact the construction industry. However, there are still significant challenges to overcome. For one, current 3D printers can only print the walls. Everything else needed for a functioning house is done conventionally. Also, the cost of construction. 3D printers with all the accompanying equipment, specialists, transport, and setup is still very high, and until the economics of scale are achieved, widespread adoption is unlikely. Nonetheless, startups around the world are working to bring the technology to the mainstream. In this video, we're going to take a look at some projects and developments in the field of construction 3D printing from this year. Thanks to Jarrett Gross for letting us use some of his footage. If you like to know the latest in construction 3D printing, check out his channel. All the links are in the description below. The company with the most success so far in bringing this technology to the market is Cobot, or Construction of Buildings on Demand, from Denmark, with their module BOD 2 printer. Together with the Perry Company, one of the industry leaders in construction engineering, which in 2018 acquired a stake in Cobot, they've printed the first ever market-ready house in Germany, followed by the largest 3D printed apartment block in Europe. The first project, a single-family two-story building with approximately 80 square meters of living space per floor, was the first 3D printed building in Germany to get fully certified under the national government's building regulations, paving the way for larger and more complex projects. Like the second project, a multi-family house with 380 square meters of living space divided into 5 apartments across 3 levels. The buildings consist of triple skin cavity walls filled with an insulating material. During the printing process, the printer takes into account the connections for water, electricity, and so on that are to be laid at a later time, allowing trades to be easily integrated into the printing process. Cobot and Perry are not just printing in Europe. Another project in collaboration with Habitat for Humanity, a nonprofit organization dedicated to affordable housing, is underway in Tempe, Arizona, to 3D print a single-family 3-bedroom house. This pilot project aims to study 3D printing to see if technology could present a scalable solution to the affordable housing shortage in Arizona by cutting construction times and eliminating the need for manual labor. For now, there are no plans for further builds, but Habitat for Humanity has made it clear that 3D printed homes are of interest to them. One more project with Cobot is underway in the US, this time by a property development firm, Alquist. They've also undergone a pilot project in Richmond, Virginia, in a private-public partnership with the state of Virginia that will study the future of affordable housing using 3D printing. The work on a 3-bedroom house began earlier this year and is slated for completion in October. Preliminary estimates show savings of 15 to 20% compared to new stick-built homes. Some of that due to less manual labor involved, and some due to using concrete instead of timber, which at the time of construction was soaring in prices. Beyond Richmond, Alquist has projects planned in several more states. The target cost of future Alquist-constructed homes is about $180,000, with a sale price slightly higher. The SQ4D, headquartered in New York, is a collective of engineers, designers, and architects with the aim of creating affordable, quality, and sustainable housing using automated building methods. They've designed and built their own 3D printer called ARCS, or Autonomous Robot Construction System, that is capable of building full-sized commercial and residential structures. In 2020, they completed the construction of their first permitted 3D printed home in the US, while their next project was the first 3D printed house to be listed for sale in the United States. The 3-bedroom, 1,400 square foot home with a 750 square foot garage has been listed for $300,000, about 80% of the median cost of comparable homes in the area. The entire wall structure of the house was 3D printed in concrete, making it stronger than conventional wood-framed constructions while being faster and cheaper to build. Icon in Austin, Texas, another well-known name in the construction 3D printing, has been advancing technology by using robotics, software, and advanced materials. Their 3D printer, the Vulcan, is a large-scale machine capable of printing homes and structures up to 3,000 square feet. It is fully automated, including the mixing and pumping of the proprietary concrete mix, which the company dubbed Lavacrete. The company has already completed several projects in the past years, all in collaborations with nonprofits, from building a community for families in need in Mexico to printing homes for a homeless community in their hometown of Austin. In 2021, Icon entered the mainstream housing market by printing several homes sold in partnership with real estate developer 3 Strands. Nestled in the fast-growing East Austin neighborhood, the development has 4 homes ranging from 2 to 4 bedrooms and 1,000 to 2,000 square feet. The first floors of these homes were 3D printed, while the second floors are conventionally framed. Priced in the mid-$400,000 range, the homes have already sold. Construction 3D printing has other uses as well besides traditional housing. NASA is investing in the research and development of space-based construction systems to support future exploration of our solar system, as it has the potential to eliminate the need to launch large quantities of building materials on multiple flights, which is cost-prohibitive. Working with NASA, Icon has printed the first simulated Mars surface habitat for a program that will simulate a realistic Mars habitat to support long-duration exploration-class space missions. Dubbed the Mars Dune Alpha, this unique 3D printed habitat is designed to serve as a base for a series of missions that will simulate year-long stays on the surface of Mars. Italian 3D printing company Wasp created a unique structure based on natural materials and made with multiple 3D printers operating simultaneously. This habitat, named Tecla, an amalgamation of technology and clay, was designed by Mario Cucinella architecture firm and made in Ravenna, Italy, with Crane Wasp Construction 3D printer. For Tecla project, 2 printing arms have been synchronized for the first time in construction 3D printing, thanks to software capable of optimizing movements, avoiding collisions, and ensuring simultaneous operation. Tecla is an innovative circular housing model that brings together research on bioclimatic principles and the use of natural and local materials, making it a pioneering example of low-carbon housing. The structure is a composition of 2 elements that merge through an uninterrupted curve culminating in 2 circular skylights. The atypical shape, from the geometry to the external ridges, enables embedding of natural ventilation and thermoacoustic systems that are difficult to replicate with traditional construction, and give life to an organic and visually coherent design. With an area of about 60 square meters, the habitat comprises of a living zone with a kitchen and a night zone with a bed. The furnishings were partly printed as well and integrated into the raw earth structure. Tecla took about 200 hours of printing and 60 cubic meters of natural materials. In the Dutch city of Eindhoven, a project is underway in which 5 3D printed concrete houses are planned to be built. It's named the Project Milestone, for it is the first 3D printed commercial housing project in the Netherlands. In 2021, the first home was completed, and its tenants received the key. Ultimately, the project seeks to complete 5 houses, with both printing technology and design becoming increasingly complex with each build. Building elements of the first house were printed in sections at a factory and then transported to the site and placed on a foundation. The final 5th house is planned to be manufactured entirely on-site. The futuristic design done by a local architecture firm is only possible with 3D printing, as it gives freedom of form. The design objective was to blend the houses naturally into their wooded surroundings, to look like boulders. The first completed house is a single-floor, 3-room house with a floor area of 95 square meters and a wooden roof structure. The project was a collaboration between the government, Eindhoven University of Technology, and industry. The municipality helped facilitate the project. The university conducted research and developed models to enable 3D concrete printing, while the construction company, Weber BMX, developed special types of concrete mortar needed for 3D printing and helped develop the printing technology. This next company, Fast Brick Robotics from Australia, is at the forefront in construction automation, with their bricklaying robot Hadrian X, that can stack the walls of a house completely autonomously. While it is not a 3D printing process per se, it does fall under the category of additive manufacturing, as a machine is building structures from the ground up, one layer at a time. Like 3D printing, the fast brick process involves the creation of a 3D computer model, which is fed to the Hadrian X that then prints the structure course by course. The company has demonstrated Hadrian X's ability to build two-story structures, as well as working along with design elements like steel-reinforced concrete columns, suspended concrete slabs, rebar, and being able to adopt a wide range of bricks and blocks from various manufacturers. The technology, over 15 years in development, is now starting to see commercial use. Hadrian X's first commercial project, for a community center in Western Australia, was completed in September 2020, and since then, they've completed construction on a number of residential buildings and launched their Wall-as-a-Service venture in Australia to third-party residential property developers. In 2022, the company aims to establish operating entities in Europe, North America, and the Middle East in preparation for deployment, establish a manufacturing supply chain, and complete design for the latest Hadrian X model in preparation for scalable manufacture. Thanks for watching. Let us know your thoughts on the subject. As always, stay tuned for more interesting videos coming soon. Bye for now.